Welcome to Business Analytics course. This is Dr. Aruna, Associate Professor from MLR Institute of Technology. In today's session, we are going to discuss about descriptive statistical measures and in that measures of association, how to execute it in Excel. Going forward, so in the previous class, we have seen what is covariance and what is correlation quotient. So covariance discusses only about the direction, whereas correlation quotient gives the information about both the strength as well as the direction part between the two variables, means the relationship between the two variables with respect to strength and also direction. Now, just if we remember these formulae, now population covariance, the formula associated with this is standard deviation of xy is equal to summation of I is equal to 1 to n. So how many observations are there? So that many observations into xi minus mu x into yi minus mu y. And we also have an Excel function covariance dot p, that is array 1 and array 2. And just let us look into even the sample covariance. So in sample covariance, here we are taking the Basel correction. So instead of taking n, we are making use of n minus 1, and this is represented as SXY. Summation I is equal to 1 to n xi minus x bar into yi minus y bar, where xi and yi stands for sample observations, x bar and y bar stands for sample means of x and y. We are going to do that all in Excel in the forthcoming slides. Now, this Excel function here, since we are representing the sample, here we are going to take covariance dot s array 1, array 2. Now, population correlation quotient. So, population correlation quotient is covariance of x and y, which we have already calculated in the previous slides, divided by standard deviation of x and standard deviation of y. For this, the Excel function associated is correl array 1, array 2. Similarly, if we look at the sample correlation quotient, though the Excel function is same, but a little bit change in the formula, summation xi minus x bar into yi minus y bar divided by summation, square root of summation xi minus x bar whole square into summation yi minus y bar whole square. We can also do in the how we have done for the population variance, that is population correlation quotient, but this also gives the same answer. Now for this, the formula is correl, that is the default function in Excel is correl array 1, array 2. Now let us switch on to the Excel and let us see. Now these are the figures, say for example, two variables which I have taken, one is x and the other one is y. So the array consisting of x is 2, 4, 6, 8 and 10, and the array consisting of y is 5, 8, 10, 12 and 15. Now for this first we are going to calculate the average for the observations under x and also for y. Now how to find out the average? It is nothing but is equal to, suppose for example, I have mentioned here mean. I am going to find out the average. So here simply keep the cursor here, put the equal to sign, because we start with equal to sign, equal to. So mean means in Excel we are having the function average, AVE. When we type, we are going to get average. Just double click this and give the set of observations. When we select the set of observations and close the parenthesis and press enter, we get the answer mean as, that is average as 6. Similarly, let us do the same for y. So again, we need not do it for y observations or the area which is included in y. So simply we can drag this for the observations under y. So here the mean for the observations under y variable is 10. Now at the same time, let us look out or calculate the standard deviation for x and y variable also, because for calculation of correlation quotient, we are in need of standard deviation of both the variables. So the formula here is just put the cursor, select the cell, press equal to symbol and just type STD. Here we are going to get standard deviation of population and also standard deviation of sample. Here we are having two. So we will go with standard deviation of population. We'll go with both of them. So first I am taking standard deviation of population. I'm taking this. I'm representing this as a population. So this six observations. 1, 2, 3, 4, 5, 6. So 5 observations are there. These 5 observations, I am taking it as a population now. I am considering it as, hence I am selecting this standard deviation P, and I am selecting all these 5 values. So close the parenthesis and press enter. So I got the standard deviation of population. Now the same way I can drag this for Y also. Now let us take, this is representing population. Let me place the bracket and write down population. Okay, let us include one more cell here, one more row where we are going to make use of standard deviation for sample. So here I am doing. Alright, instead of population here we would be mentioning sample, because we are going to take here sample function. So here when we take about the standard deviation with regards to population sample, so place the cursor, press equal to sign, standard deviation dot S. We are having below P standard deviation of S. Double click and select all the observations. Close the parenthesis and press enter. We get the value. Now the similar way we can do it for Y variable also. Let us see how many observations are there. Now here is equal to count. So the count gives number of observations here. Say here we are having 5 observations. We are going to get 5. Okay, so here also the same way we are going to get 5 observations. Now that we are done, now let us proceed to the second step. Here in the third column we are supposed to find out the deviations with respect to mean. So that is x minus xi, where xi is nothing but the mean of the first variable. So here I am just taking is equal to symbol. This is the first one, that is C4 minus, our mean is in the cell C9, but when we are going to drag for the rest of the cells, it is going to take C10, C11 like that. So for this reason we are supposed to give absolute address. So we simply give the dollar symbol. So when we press the dollar symbol, it takes the absolute address. So we are giving $C $9 and press enter. So we got 2 minus 4, that 2 minus 6, that is minus 4. Now keep the cursor here, and on this plus symbol simply keep and drag it. We are going to get it for all the observations. In the same way, let us do it for Y variable is equal to value of Y observations, first observation under array Y minus, now we are having here the mean of the second variable Y. So it is under D9 cell, but here we are supposed to give the absolute address. We put the dollar symbols in front of D9, that is $D $9. So we are pressing F4 shortcut key. When we press the F4 shortcut key, we are going to get $D $9 automatically and press enter. So here 5 minus 10, which represents minus 5. Yes, our answer is correct. Now keep the cursor here on the plus symbol, simply drag it. So we got the value Y minus Yi. Now here in the fifth column, we are having the multiplication of third column as well as fourth column. So xi minus x minus xi into Y minus Yi. Now simply put the cursor here, after placing the cursor over there, press the equal to sign. Now select cell E4 multiplied by, means asterisk symbol, multiplied by F4 and press enter. So minus 4 into minus 5, it is plus 20, because minus into minus gets positive, becomes positive. So simply drag the values. Now here xi minus xi minus x bar we were taking in the formula. So here instead of x bar, I am using the letters xi. In the formula we were using y minus y bar. So here we are using y minus ya. Now here we are supposed to do summation. Summation I is equal to 1 to n. How many observations are there? 5 observations are there, and these 5 observations of summation we are supposed to do. So we are going to place the cursor here, press the equal to symbol and use the summation formula, that is sum. So press sum and select all the observations. Press close the bracket, press enter. So we got here 48. Now the formula is covariance is equal to summation I is equal to 1 to n xi minus x bar into yi minus y bar. Now the same thing divided by n if it is population covariance. So the same formula we are going to use it now. So here we have kept here population covariance, sample covariance, population correlation quotient and sample correlation quotient. Now since that we have done till this year, we are now going to make use of the formula for population covariance. So is equal to population covariance is equal to summation I is equal to 1 to n x minus x bar into y minus y bar. So here I am representing x and xi, y and yi. So simply I am making use of this like G9 divided by how many observations are there? We are going to use the population first case. So population means here the number is n. So simply put n. We are getting the answer 9.6. Okay. Now when it comes to sample covariance, we are going to make use of n minus 1. We are going to make use of n minus 1, that is the basal correction. So how we are going to do that? If you can see here, place the cursor here is equal to the value summation of xi minus x bar and yi minus y bar. So I am making use of G9 divided by, it should be n minus 1 because it is a basal correction. So here my n number is 5, but here I am supposed to take, I am going to reduce one number. So for this what I am going to do is I am going to make use of the absolute address of CF4 minus 1. But for this we are going to place here the bracket because it should know that this is the denominator part, and hence press enter. Now if you can see, we are getting the answers for sample covariance as 12. Now let us make use of the default functions that have been already available in Excel. If we look at the default functions, we already have for covariance is equal to covar. If we just press COV, we are getting the options like covariance.p, covariance.s and covar. So as we have seen in the previous session and in the previous slides also, to find out the population covariance, the default function is in Excel is covariance.p. So simply select this and give the array. So array is array 1 which represents x, comma, and the second one is array 2 that is which is representing y. So simply press enter. So we are getting the same answer. If we can look at here, it is 9.6. and here also it is 9.6. So we are getting the similar kind of answer. Now let us see, here we got 12 as sample covariance. Let us see this sample covariance as 12. Now let us see, by making use of function, are we going to get the same answer or not? Now is equal to covariance dot s. So again array 1, array 2. So for array 1 we are selecting the observations under x variable, and here again the observations under y variable which represents array 2. Close the parenthesis and press enter. Yes, absolutely we are getting the same answer making use of the Excel function, default function. So in both the cases, whether it is population covariance or whether it is sample covariance, by making use of the formula and also by making use of functions, we are going to get the same answer. Now let us see how to calculate population correlation quotients and also sample correlation quotient. We have seen that by default Excel is having the same function with respect to what I can say, calculation of correlation quotient of population and correlation quotient of sample. So before that, let us go with the formula. And the formula for population correlation quotient is whatever the covariance we are getting with respect to population divided by standard deviation of X and standard deviation of Y. Now here, if we look at the formula is equal to, we have already obtained population covariance which is existing in cell C16, which is existing in C16, divided by standard deviation of X and standard deviation of Y, and that too we are representing the population. So I am going to take standard deviation of population of X multiplied by standard deviation of Y with respect to population. So here we are getting 0.99654. Now if we truncate these values, let us reduce this to 5 digits. So it is coming around 0.99655. Now similarly, let us do for sample correlation quotient also is equal to. So we have already calculated sample covariance. So which is the value is 12. So which is existing in C17. So I have used the C17 divided by standard deviation of sample X. So here C11 multiplied by standard deviation of Y sample, and close the parenthesis we are getting. Now if we truncate this to 5 decimals, or we are confining ourselves to 5 decimals, we are getting. Now as I said, in both the cases, whether it is population correlation quotient or sample correlation quotient, we are going to get the same results. That's the reason in Excel by default, whether it is population or whether it is related to sample, we are going to have only one function by default, and that is equal to correl. When we type the 2 letters or 3 letters, automatically we are going to get the function correl. Just double click this and give the array. So array 1 which represents X and the other array 2 which represents Y, and close the parenthesis and press enter. So here also if we reduce the decimals, yes, we got the same answer, 0.99655. Now let us see, of course, we are going to use the same for default function, whether it is population correlation quotient or sample correlation quotient. So we are again using correl function. So simply double click and give the array. So when we give this, automatically we are going to get the same answer, because correlation quotient would be same irrespective of whether it is population or whether it is sample. So this is how we are going to find out population covariance, sample covariance in Excel using formula and also using functions. And the similar way we can also find out population correlation quotient and sample correlation quotient. Both are same, means we would be getting the same result, whether it is with respect to population or whether it is with respect to sample. Yeah, and that's the reason in Excel we have only one default function. We are not having with respect to population and with respect to sample size. So we only have one function, that is correl. Now if we look at the next slides, so coming back, So we have seen sample correlation quotient, population correlation quotients in today's session. How we are going to do it in Excel. And as you have seen, there is one more formula, standard deviation, the sample covariance of x and y divided by standard deviation of x and standard deviation of y. That also we have seen. And now, so in today's session, we have seen covariance and correlation quotient, though we have come across all these formulae in the previous sessions, but in Excel we have seen that there is no difference in the correlation part with regards to either it is population or sample, but we can see the differences with respect to covariance, because in Excel we are having covariance.p for population covariance and covariance.s for sample covariance, and also the formulas also differ, because there we are taking standard deviation of population in the denominator part, standard deviation of sample in the denominator part when it comes to the sample covariance. This is how the difference lies when it comes to covariance, and the result is same when it comes to correlation. So we have seen all this formula, and yes, there is other alternative correlation function. We can even use that Pearson array 1, array 2. Simply we can use this formula, because Pearson correlation function or correlation quotient is one and the same. And that's all for this session. Stay tuned. Have a good day.